Hi everyone, welcome to Code with Toby YouTube channel. This is the first video in the playlist Crack Your HD interview. In this video, we will see OOPS topics and question which you should know if you have any upcoming HD interview. So, without any further ado, let's start with the first question, which is what is OOP and its advantages. So, what is OOP? It is a programming paradigm which is based on object. What is object? Object are instances of a class. What is class? Class is a blueprint of a object which contain data and methods which operate on that data. So what are the advantages of using OOPS? The advantages are: the first advantage is code reusability, which we can achieve using inheritance. The second advantage is data security, which we can achieve using encapsulation. The third advantage is scalability, which we can achieve using polymorphism. And the fourth advantage is to reduce the complexity of the code, which we can achieve using abstraction. Now, if you want your interviewer to keep asking question on OOP, then you should not end your answer here. You should also discuss the OOPS principle with the interviewer. So the OOPS principle are encapsulation, abstraction, inheritance, and polymorphism. So after discussing this OOPS principle, there will be a 90% chance that the interviewer will ask you to explain these four pillars of OOPS, which we also call as four principle of OOPS. So let's see one by one. Let's start with encapsulation. What is encapsulation and what benefit we get using encapsulation? We already see that we get data security if we use encapsulation. So what is encapsulation? It refers to the practice of bundling data and methods that operate on that data into a single unit, which we also call as class. And also it restricts direct access to the object details by using access modifiers such as private, public, and protected. So if you see this code, here we have a class which name is encapsulation with some data, and a constructor which assigning value to this data when we creating an instance of this class. And we have two functions. One is to set the data and one is to get the data. So here we can see how encapsulation is bundling the data and methods into a single unit, which we also call as class. And it's using access modifiers to prevent the unauthorized access to this data. Now let's move towards the next OOP principle, which is abstraction. So what benefit do we get by using abstraction? So it helps to reduce the code complexity. So what is abstraction? So it is the process of hiding implementation details and exposing only the necessary functionalities. How we can achieve it? We can achieve it using abstract classes and pure virtual function. So here we have a code in which we have an abstract class. So how we can define an abstract class? So if a class have at least one pure virtual function, then that class become an abstract class. So how we can define a pure virtual function? To define a pure virtual function, we have to use a keyword virtual, and then we have to assign it to 0. We are not actually assigning it to 0, it's just the method to define a pure virtual function. Then we have a derived class where we are inheriting this base class, and in this derived class we are defining this pure virtual function. So here, as you can see, we are using a keyword override. So if we don't use override here, will it still work? Yes, it will work, but it's always best to use override. Why? Override Here, override will check the function signature and the class signature for you. Suppose if you have not properly defined the function name, then it will give you a proper error that you didn't have defined the function name properly. But if you don't use override here, then you will not get the proper error. Okay. So now because abstraction can be achieved using abstract classes and pure virtual function. So there might be a case you have to explain this also. So this question can come also, which is what is abstract classes and pure virtual function. So what is abstract classes? A abstract class is a class that cannot be instantiated, meaning we can't define an object for that class. So how we will be able to use the functionality of that class if we don't even create an instance of that class? So to do that, we have to define another class which will inherit this abstract class, and in that class we have to define that pure virtual function, and then we can create instance of the derived class to use the functionality of this base class. Okay, so why we use abstract class? To create a common interface for derived classes. What we will get by doing that? We are enforcing some function that must be implemented by derived classes. And we already discussed this point where a class become abstract when it contain at least one pure virtual function. Now here we have one of the most common question where interviewer will give you the code and will ask you if that code is correct or not. So here we have an abstract class with a pure virtual function, and then we are inheriting that class in a derived class and then defining that pure virtual function in that derived class. So here we can see we can't create object of that abstract class which we already discussed. So if he will give you this code, you have to simply tell that it will give you the compiler error. The reason, because we can't create object for abstract classes. Can we create object for derived class? Yes, we can create object of derived class only if we have defined the pure virtual function in the derived class. So what would happen if we don't define pure virtual function in the derived class also? Then that class will also become an abstract class. Now, this is one of the most important one. Can we create a object of derived class using the pointer of abstract class, meaning the parent class? Yes, we can create. So here when it will call this show function, it will call the show function of derived class, because here it is using late binding where it will do the binding during the runtime. Now let's see what is pure virtual function. So a pure virtual function is a function that has no implementation, which we already seen in the base class and must be overridden in the derived class. If we don't overriden it, then that derived class will also become an abstract class. And to declare that pure virtual function, we have to assigning it by 0 in the function declaration. So this is just the method to define the pure virtual function. We are not exactly assigning it to 0. Now let's move towards the next OP principle, which is inheritance. So what the benefit of using inheritance? The benefit is code reusability. And what is inheritance? It allow a class, a derived class, to inherit properties and behavior from another class, and that class is base class. So there are several types of inheritance. We have single inheritance, we have multiple inheritance, we have multi-level inheritance, we have hierarchical inheritance, we have hybrid inheritance. We will see each of them one by one. Let's start with single inheritance. So in single inheritance, a derived class inherit from only a single base class. So here, as we can see, we have a parent class where we have a function which printing something, and we have a child class which is publicly inheriting parent class, meaning now this child class have access to method and properties of this parent class. So here we have used a term called publicly inherit. What's that supposed to mean? Let's see that also. So there are three types of inheritance mode: public, protected, and private. So if we use public mode of inheritance, then the public member of parent class will remain public, the protected member of parent class will remain protected, and for the private member of parent class, it just can't be inherit. To access the private members of parent class, either you have to create the instance of the parent class or you have to use the concept of friend classes. And if we use a protected mode of inheritance, then the public member of parent class will become protected, and the protected member of parent class will remain protected. And for the private mode of inheritance, the public member of parent class will become private, and the protected member of parent class will also become private. So now let's move towards the next type of inheritance, which is multiple inheritance, where a derived class inherit properties and methods from more than one base class. Here we have two base classes and one derived class which is inheriting properties from multiple base classes. Now this derived class have access to properties and methods from both base 1 class and base 2 class. Now let's move towards the next type of inheritance, which is multi-level inheritance. So in this type of inheritance, a class is derived from another derived class, meaning we have a base class which is inherited by a derived class, then the derived class is again derived by some other derived class. Meaning here, as you can see, we have a class named as grandparent which is inheriting by parent class, then the parent class is again inheriting by child class. Now this child class have access to properties and methods from both parent and grandparent classes. Now let's move towards the next type of inheritance, which is hierarchical inheritance. In this type of inheritance, multiple derived class inherit from a single base class. Meaning we have a base class and that base class is inherited by multiple derived classes. Example, we have here a base class which is inherited by derived 1 class and it also inherit by derived 2 class. Now both of these classes have access to properties and methods of this base class. Now let's move towards the next type of inheritance, which is hybrid inheritance. So what is hybrid inheritance? It is a combination of multiple types of inheritance. It usually involves virtual base class to prevent ambiguity. We will see what is this ambiguity. So here, as you can see, we have a base class which is inheriting by two derived classes, and that derived class is again inheriting by some class. So if you look carefully, it using two type of inheritance. One is multi-level inheritance and the other one is hierarchical inheritance. Here in this example, we can see we have a vehicle class and a fare class. The car class is inheriting the vehicle class and the bus class is inheriting both vehicle and the fare class, kind of creating a hybrid of multiple types of inheritance. Now there is one special case of hybrid inheritance which is also known as diamond problem, or we can say multipath inheritance. So in this problem we have a single base class which is inheriting by two intermediate classes. Now these two intermediate classes are further inheriting by a single derived class. So what's the problem in this? So if you look in this example where we have a vehicle class which have a constructor and a function named as so, and then we have two other classes. Both of these classes are inheriting this vehicle class, and then we have another class hybrid which is inheriting both car class and bus classes. Now in our main function we are creating an object, meaning we are creating an instance of this hybrid class. And because hybrid class have inherit this car and bus class, and this car and bus class have inherit this vehicle class, hybrid class also have access to the properties and methods of this vehicle class. So if we try to call this function, it will give us ambiguous reference error. Why it's giving us a reference error? The reason is both car and bus class have copies of this vehicle class. So when we are trying to access this so function, it have multiple copies of this vehicle class, and because of that we are getting reference error. Now to solve this problem we can use virtual inheritance, virtual hybrid inheritance. So what is this? So in this we are inheriting this vehicle class virtually. By using virtual keyword here, we are using a single instance of this vehicle class among all the classes which are inheriting this vehicle class. Now because all the classes which are inheriting this vehicle class have single instance of this vehicle class, so now if we try to call this so function, it will successfully print the vehicle class because now hybrid don't have multiple copies of this vehicle class. It has single instance of that vehicle class. Now let's move towards the next OOP principle, which is polymorphism. So what is polymorphism? Polymorphism allow the same function to have different behaviors in different classes. What's the benefit of using it? It provides us the scalability. So there are two types of polymorphism: compile time polymorphism and runtime polymorphism. So before moving towards the compile time and runtime polymorphism, there is one important question comes here. So which is, what is binding and the difference between dynamic binding and static binding? So what is binding? So binding is like telling the program which function to call when you write the code. There are two types of binding: static binding and dynamic binding. Static binding is also known as early binding, and dynamic binding is also known as late binding. In static binding, the program decides which function to call at compile time, meaning before the program runs. It happens in compile time polymorphism. And in dynamic binding, which we also call as late binding, the program decides which function to call at the runtime, meaning when the program is actually running, and it happens in runtime polymorphism. Now, let's see what is compile time polymorphism. So, it can be achieved using function overloading and operating overloading. We will see each of them. And it is called compile time polymorphism because the function or operator that needs to be executed is determined at compile time, which we already seen how static binding work. Now how we can achieve compile time polymorphism? We can achieve it using function overloading or operating overloading. So what is function overloading? In function overloading, so it allow multiple function with the same name. Here as we can see, all these three function have same name, but either they should have different number of parameter. As we can see here, we have two numbers of parameter, or and here we have three number of parameter, or the type of parameter should be different. Here we have the type is int, but here the type is double. So when we create an object, or we can say when we create an instance of this math class, and when we will try to call this add function by passing this 5 comma 10 parameter, then it will call this first function. But if we try to pass three number of parameter, then it will call this third function. Now let's move towards the next topic, which is operator overloading. So in operator overloading, it allow to add a custom behavior for built-in operator. Example, addition operator. So was the general use of addition operator is to add two numbers. But by using operator overloading, we can add some custom behaviors to this built-in operator, such as to concatenate multiple strings into a single string, or to add complex numbers. So here in this code we have a class with the name as complex, and in this class we have two data fields. One is for real value and the other one is for imaginary value of complex number. And then we have a constructor which is assigning the real value and imaginary value to these data fields when we are creating an instance of this complex class. And we have a function display which is printing the real and imaginary value of a complex number. And here we are performing operator overloading on addition operator. So to define a operator overloader, the name should be same as the class name, and then you have to provide the operator which you want to overload by using the keyword operator and then the symbol of that operator. Then you have to pass the object which you want to use to do some operation on current object, and then we are returning the resultant object. So here as you can see, we are passing this object as const. What's the reason behind it? Because we don't want to change this object, we just want to use it to perform some operation. And we also passing it as a reference. What's the reason behind it? We just don't want to call multiple copy constructor. So here we have defined two object, two instance of this complex class, where in first object we have passed 3 as real value and 4 as imaginary value, and in object 2 we have passed 1 as real value and 2 as imaginary value. Then we have create another instance of this complex class named as C3, and here we are performing a addition between complex number. So here it will call this operator overloader and will perform the addition between complex number. And when we will call this display function, it will print the real and imaginary value of the resultant complex number, which we will get by adding this C1 and C2. So here it will print 4 as real value and 6 as imaginary value. Now there is one important question on operator overloading, which is what is prefix and postfix operator. So prefix operator, it is an operator in which the operation happens before the value is used, and in the postfix operator the operation happens after the value is used. So when we generally use them, They are commonly used with increment and decrement operators. You can also use with other operator also. So let's see them what is actually prefix and postfix operator are. So here as you can see in this example, we have a counter class where we have a count data field as type of int, and then we have a constructor which is assigning C this to count when we are creating an instance of this counter. Then we have two operator overloader. The name of operator overloader should be same as the class name, and then we have to provide the operator which we want to overload with the keyword operator and the symbol of the operator which we want to overload. Here we are using 2 plus sign, or we can say that increment operator. So in prefix increment, we are first performing the operation, then we are using the value. But in postfix increment operator, we are first creating a temporary object where we are storing a copy of the current value, and then we are performing the operation, and the value which we are returning is the value which was before the operation was performed. So here as you can see we use int, but here we didn't use int. What's the reason behind it? This is used as a dummy parameter to differentiate between postfix and operator, because the symbol of the operator is same for both of them. So to differentiate between the operator, here we use the dummy parameter. Now let's move towards the next type of polymorphism, which is runtime polymorphism. Runtime polymorphism can be achieved using function overriding in virtual functions. So it happens when the function to be called is determined at runtime, not at the compile time, which we already saw in late binding, or we can say in dynamic binding, where the function which needs to be executed is determined during the runtime. So what is function overriding? So in function overriding, a function in a derived class has the same name and return type and parameter as a function in base class, but we provided new implementation in derived class. So if you can see in this example, we have a shape class which is inherited by a circle class. In this shape class, we have a virtual function name is draw, and it a non-return type is just printing something. But in circle class, we are overriding, meaning we are redefining this draw function, and we are printing some different thing. So when we will create a object of circle class with the pointer of the shape class, and when we will try to run this draw function by using the pointer of shape class, it will call this draw function, because here it is using dynamic binding because of this virtual keyword. It will determine which function need to be executed during the runtime. So when we will call this draw function, it will call the draw function of this circle class. So this is it for this video. So if you have learned something new from this video, please give a like and share this video. And if you are new to this channel, please subscribe this channel and press the bell icon to get the latest notification. There will be some more videos on the OOPS question. Then we will move toward the computer network and operating system and also DBMS. So thank you and bye bye.